Question 10. So what we need to do here, it says dh over dt. So just have a look at this. If we were to multiply by this over here, bring the 40 over here and h over here, let's just see what that actually gives us just there. So, and then, like I say, the art with these questions really is just kind of recognising what needs to be done. The actual maths involved isn't generally too bad. So I've just put that dt up over here. Let's bring the 40 up over there. Kind of makes sense to have it there, I suppose. So it could stay here. And divide through. Right, okay. This is just telling me to integrate, isn't it? Right. If I integrate this, it gives me 40 ln h there. And then that's going to equal, now if I integrate this, it's actually going to give me 4 sine 0.25 t. Now you might need a little bit of practice at doing that. What I do is I think about, right, what would I differentiate that would give me this is sort of part of my answer. Right, okay, let's just tidy this up a little bit. I don't like the 40 being there, so maybe we should have probably written it like this. So 4 divided by 40, so that's 0.1 sine 0.25 t. Now that's going to be, remember there's going to be adding some constant in there. So what are we going to do next? Hey, wait a minute. What we're told up here, so we're trying to show this thing just here, but look at the information that we're told. Why has it told me this information? Well, look at this here. It says given that the passenger is 5 meters above the ground at the start of the ride. So what does that mean? That means h is 5 when t is equal to 0. So if we sub that information in, what we're trying to do is trying to find out that bit. So if we sub this information in, that will give me ln 5 equals 0. Oh, wait a minute. What's this going to be? Sine 0 times 0.1. Isn't that just 0? There you go. So C must equal ln 5. So if I now write this down, I've got ln h equals 0.1 sine 0.25 t plus ln 5. Now wait a minute, I'm just looking back up here. Sometimes if you get a little bit stuck and you're a little bit unsure what to do, there's kind of big clues over here. Hey, wait a minute. If we just take e of both sides, don't we just get this? That'll give me, that's going to give me the answer, isn't it? I take the e, 0.1 sine 0.25 t, and then that's going to be multiplied by 5 times 5, which is exactly what we wanted. All right, brilliant. You just need to think about your rules of indices a little bit here. Okay, so state the maximum height of the passenger above the ground. So what does that actually, what we need to think about? If I think I'm just going to put me 5 there, just so it's a little bit nicer. Right, so what am I interested in just here? Well, I'm interested in, when's the maximum going to happen? The maximum's going to happen when this bit is equal to 1. That's the highest that can possibly be, right? We know about sine and cos. What's the biggest it could be? It could be 1. So therefore, the max height would equal 5e to the 0.1. And if you work that out, that comes to, I think it's 5.53 meters. Okay, so there's part B. Part C. So it says the passenger reaches the maximum height for a second time, t seconds after the start of the ride. So again, it's all to do with this idea here. When is the maximum actually going to be achieved? It's going to be when this bit equals 1. So if we take the, oops, that's just out of shot there, isn't it? Right, so if we take the inverse sine of both sides, we will find out that 0.25t t is equal to pi over 2, or maybe 5 pi over 2, because remember we're interested in the second occasion that this happens, and 0.25t. So if I multiply this by 4, that gives me 20 pi over 2, so that's equal to 10 pi, or if you prefer, that's 31.4 seconds. There you go.